Hello, grade 8s. I hope you're doing well. Today we'll be looking at the topic of numeric and geometric patterns. All right. So, the whole thing with patterns is that you're trying to see if there's a trend in the numbers as they progress. And once you can figure out what the trend is, then you can rightfully or accurately determine the continuous trend, future trends, or even past trends. Okay, but that's if you can notice a specific trend. Now, when we start with numeric patterns, I'm just going to define what that is. So, a numeric pattern is a specific number that is added to or subtracted from the previous number in the sequence to get the next. Okay, therefore, we have a common difference. Okay, so basically you're taking a number, a specific number that you either add or you subtract in a specific sequence or in a particular sequence, all right, in order to get a future number, the next number. Okay, so yeah, and that number that you keep adding or subtracting is a common difference. Now let's look at some examples over here. So with the first pattern, I'm just going to put number 1 over there so that you know which one I'm talking about. So we have 0, 2, 4, 6, etc. So if we look at the rule, what happened? For me to get from 0 to 2, I had to add 2. For me to go from 2 to 4, I also had to add 2. So the rule is add 2 to a number to get the next term. Now, if I want future numbers, I'll have to add 2, right? So from 6, if I add 2, I'll get 8. From 8, if I add 2, I'll get 10. And from 10, if I add 2, I'll get 12. Okay, simple as that. And then in the second pattern, I have 32, 24, 16, 8. So the numbers are going down, they are not increasing. And if they are going down, it means I am subtracting something. All right, if I go from 32 to 24, what would I have subtracted? I would have subtracted 8. Okay, if you couldn't see between 32 and 24, look at between 16 and 8. All right, or between 24 and 16. I keep subtracting 8 from a number to get the next term. And if I'm looking for the next 3 terms from 8, if I subtract 8, I'll get 0. And if I subtract 8, I'll get negative 8. Again, if I subtract 8, I'll get negative 16. Remember, we spoke about integers. Integers are numbers from negative infinity to positive infinity. Okay, by now you already know that the negative numbers do exist. It's not a new phenomena. All right, it's not a new it's not new information for you. So like I said, with numeric patterns, you're either getting numbers, you're adding a specific common difference or you're subtracting a common difference. Now let's go to an exercise. Okay, so exercise 4.1, find the common difference. The common difference here, I need to see, for me to go from 1 to 8, I can either say what is 8 minus 1. Okay, I get 7. And if I say what is 15 minus 8, that's how I get the next term. I see that it's 7. Okay, if I still am in disbelief, I can say what is 22 minus 15? I get 7. So basically the common difference, I'm just going to call it D, that is 7. Okay, that's my answer. That's how you basically try to get the common difference. You take the bigger value minus the previous value. All right, now for B, I go from 7 to 3 to negative 1. So here we had an increase, right? But now here I can note that we have a decrease. So from 7 to 3, what would I have subtracted? Okay, what am I subtracting here? I'm subtracting 4. Okay, and then from 3 to negative 1, what am I subtracting? Okay, so basically if I look at my number pattern, so I go 3, 2, 1, 0, negative 1. So I'm at 3 at the moment. what would I have subtracted in order to get negative 1? Let's see. 1, 2, 3, 4. So again, I'm subtracting negative 4. Or rather, I'm subtracting 4. Okay. So basically, my common difference, I'm just going to say that's D. That's basically equal to negative 4. And then here, this exercise C, I have negative 22. My next term is negative 16. And then my last term is negative 10. So basically, I have an increase in this trend. I'm adding something. All right. Again, if this is a little bit tricky for you, draw for yourself a number line. So I have negative 22, negative 21, negative 20, negative 19, negative 18, negative 17, negative 16. Okay. Otherwise, in my calculator, I could have said negative 16 minus negative 22. And a minus and a minus create a plus. So it's negative 16 plus 22. Okay, that's how you're going to get your answer. But let's see. If I go from negative 22 all the way to negative 16, what would I have added? So 1, I would have added 1, 2, 3, 4, 5, 6. See, I needed a positive 6. And even if I'm at negative 16, going all the way to 10. So 16, 15, 14, 13, 12, 11, 10. Okay, let's see. So it's 1, 2, 3, 4, 5, 6. I've added 6. All right. Ooh, I've scribbled quite a lot. But basically my answer, so there we have negative 4. Let's just erase this so that we can write our answer properly there. But you get the drift, right? This is the kind of working out that you do for yourself with a pencil so that you understand what it is that you are doing. And you can see that therefore the common difference is basically positive 6. And there we are done with exercise 4.1. Now it says exercise 2 in 4.1, state the next 5 numbers in the pattern. All right, so here we need to see what the trend is. For me to go from 3 to 7, by the way, it's an increasing trend. Nah? So from 3 to 7, if you don't know, you just say 7 minus 3. I'm adding 4. Again, from 7 to 11, I'm going to say 11 minus 7, and that's basically 4. So I see then, it's always good to make sure, okay, I always test the numbers that I'm given just to make sure that it is 4 for all of them. Okay, so as such, I can then get the next 5 numbers. So I'm going to say 11 plus 4, which is basically 15. And then 15 plus 4, that is 19. 19 plus 4, that is 23. 23 plus 4, that is 27. 27 plus 4, that is 31. That is the next 5 terms. Okay, and then now let's go to B. 3, what will I need to get to 20? Well, basically I need 17. Whew, such a huge leap. Again, from 20 to 37, I need 17. My goodness, I am going to need my calculator. Let me just get it quickly. Okay, unless if you wanted to do it in your head. So 37 plus 17. Oh my goodness, that's going to take us forever. Okay, so yeah, 7 plus 7, that's 14. 3 plus 1, that's 4. So 54. Okay, now let me go take my calculator because these numbers are getting big and we do not want to waste time. Okay, we have our calculator there. We were at 37 plus 14. No, plus 17. I'm thinking, what in the world is going on? 37 plus 17, that's 54. And then we're going to add 17 again. So we get 71. Okay, that's the second term. And then add 17. We're getting 88. Okay, then we have 105. Okay, and then we have 122. So those are the next 5 terms. Awesome. Now C, all right, 21 to 14, I see we are going down. Okay, and what do we do then? So if we're gonna say 14 minus 21, that's basically minus 7. I'm subtracting 7. So for me to go from 21 to 14, I had to have subtracted 7. Again, to go from 14 to 7, I subtracted 7. So 7 minus 7, that's 0. 0 minus 7, that's negative 7. Negative 7 minus 7, that's negative 14. And negative 14 minus 7, that is negative 21. And the last term that they need, negative 21 minus 7 is negative 28. And if you really do not believe me, go and put that pattern in the calculator. So 21 minus 7 is 14, minus 7 is 7. Then you get 0, negative 7, negative 14, negative 21, negative 28. There we go. Cool. And yeah, so we are done with the numeric patterns. Geometric patterns. All right, so previously we spoke about numeric patterns, and basically you have a specific term which we call the common difference, which you either add or you subtract from your pattern. Now with a geometric pattern, we will talk about ratios. And this time we're going to have a common ratio. And that ratio, we're either going to multiply it, right, or divide. But instead of dividing or avoiding dividing, we're either going to multiply with a whole term or multiply with a fraction. Okay, I hope I didn't lose you there, but let's just read what it is when we refer to a geometric pattern. So basically, a specific number is multiplied to the previous number in the sequence to get the next number in the sequence. All right, so there's a common ratio. And like I said, we are multiplying. If you want to increase this pattern, we will multiply by a whole number. If you want to decrease the pattern, we're not dividing, but rather we will multiply with a fraction. And you'll see what I mean once we start looking at examples. Okay, so if we're looking now at the first pattern, let me just put there number 1. For me to go from 1 to 2, I'm not adding here. Remember, adding and subtracting has to do with numeric patterns. Now we are looking at common ratios here. We're looking at the geometric pattern. So for me to go from 1 to 2, I would have multiplied by 2 to go from 1 to 2. 1 times 2 is 2. And then for me to go from 2 to 4, I still would have multiplied by 2. So 2 times 2 gives me 4. From 4 to 8, I multiply by 2. And from 8 to 16, again, I multiply by 2. So here we can see, if we're looking at the rule, we are basically multiplying by 2 to get the next term. Okay, now if I'm looking for the next 3 numbers, 16 multiplied by 2 is 32. And 32 multiplied by 2 is 64. And 64 multiplied by 2 is 128. All right, now another pattern. And this is an increasing pattern, right? Meaning we multiplied by a whole number. Now the second pattern, we have 1,000, then we go to 500, and then we go to 250. So here, our pattern is basically going down. It's decreasing. Our sequence is decreasing. All right. And now you can see here from 1,000 actually to 500, we divided by 2. But I know my rule here, I wrote divide by 2, but I actually want to stick to the, what do you call this? I want to stick to the definition that we actually started with. And this definition was that we multiply a specific number to the previous number in the sequence. So here, instead of dividing by 2, we are going to multiply by a half, right? Because we went from 1,000 to 500. So if you take 1,000 and you multiply by a half, you will get 500. And if you take 500 and multiply it by a half, you will get 250. Okay, so basically I would say multiply by a half to get to the next term. Okay, so if we continue in that trend of multiplying by a half, you'll see 250 multiplied by a half is 125, which we see there. 125 divided by, or rather multiplied by a half is 62.5, and then multiply by a half, we get 31.25. Fair enough. And then number 3 going to 12, we see this in an increasing pattern. So what did we multiply by to get to 12? If you remember your multiplication tables, we multiply by 4 to get to 12, and 12 also times 4 is 48, and 48 times 4 is 192. So what's the rule? We multiply by the number 4 to get to the next term. And if we get the next three numbers, 192 multiplied by 4 is 768, and it increases as you see, 3072, 12,288. So now let's get to the exercise. It says, state the next three terms and describe the rule of the pattern. So here I see I go from 3 to 9 to 27. So this is an increasing pattern. Okay, so I'm going to multiply by a whole number, not a fraction. So in order for me to go from 3 all the way to 9, what would I have multiplied it by? Okay, another way of looking at it, I'll take the second term, which is 9, and divide it by the first term, which is 3. There I get 3. Okay, just like we did with the numeric pattern, where we take the bigger term, subtract by the second term to get the common difference. We're doing the same thing as well, but this time we're getting a common ratio. So it means 3 times 3 will give me 9. And then if I take 27 and I divide it by 9, I'm going to get 3. So 9 times 3 will give me 27. So now 27 multiplied by 3, because I need to get the next, am I adding there? I need to multiply, because I'm getting the next three terms, right? So 27 times 3, that is 81. And 81 times 3 is 243. And 243 times 3 is 729. Okay, those are the next three terms. And then B, I'm going from 1,200 to 600. Okay, so I'm taking my bigger term, 600. I'm going to divide by my first term, 1,200. I can see that it's going to be a half, but if you are not sure, do use your calculator. But you know that in the exams, I don't think they allow you to use calculators, so be very careful. So what is my common ratio? Then I'm going to name my common ratio. I'm going to say R. So that's a half. So from 1,200 to 600, I multiplied by a half. And from 600 to 300, I multiply by a half too. Okay, so let's see. 1,200 multiplied by a half. Okay, by a half is 600. And if I multiply it by a half, I get 300. And if I continue, then I'm going to get 150. The next one is probably 75. And the next one, 37.5. Okay, that's why it's good to use the calculator sometimes. Okay, and there we go. And if you're not allowed to use the calculator, unfortunately, you're going to have to divide however way you were taught. All right, you would basically have 75. Remember, there's a video on fractions, and multiplied by a half, which is basically 75 over 2. Okay, now I'm looking at long division now. So 75 is the square root. Let me just do, 75 divided by 2. 7 divided by 2 is 3. 3 times 2 is 6. This is how we were taught. I don't know how you guys were taught. Okay, So 7 minus 6 is 1. 15 minus 0. Sorry, 5 minus 0 is 5. So I have 15. What's 15 divided by 2 is 7, 5. And that's it. 37,5. And then C, the next three terms. So I see going from 5 to 25 to 125. This is an increasing pattern. So I'm going to ask myself, what is 25 divided by 5? It's basically 5. So here, I'm multiplying by 5 to get to the next term. Okay? And again, 25 multiplied by 5 is 125. Now, 125 multiplied by 5 is 250. 250 multiplied by 5 is 1,250. 1,250 multiplied by 5 is 6,250. Those are the three terms. And then we have here, fill in the missing values in the sequence. Okay, so you have to figure out then what is the common difference. And then you have 8, 24. So because we're dealing with common ratios here, you can say 24 divided by 8 to get what the common ratio is. And that's basically 3. So I see here that I'm actually multiplying by 3 to get to the next terms. And if you don't believe it, test it. So 8 multiplied by 3 is 24. 24 multiplied by 3 is 72. Now, what is 72 multiplied by 3? That's 216. And to test it out, 216 multiplied by 3, it is 648. Yes, we have 648. So there we go. We are confident in the missing value that we just filled in. Now, from 4 to 12 to whatever, to 108 to whatever, I see that I have an increasing pattern. All right. And because it's an increasing pattern, I am going to multiply by a whole number. And I see 4 times 3 actually is 12. 12 times 3 is 36. 36 times 3 must give me 108. So let's check. 36 times 3, 36 times 3, 108. And 108 times 3 is 324. Great. So we are confident there. Now I see for C, 750, 150, 6. So I have a decreasing pattern. So if I say 150 divided by 750, what do I get there? Okay, because we need to know what our common ratio is. 150 divided by 750, I get a fifth. So basically, I am multiplying by a fifth in order to get to the next number. Okay, so 750 multiplied by 1/5, I get 150. 150 multiplied by 1/5 is 30. And 30 multiplied by 1/5, that is 6. All right. And that's basically it. We have filled in the missing values. Sorry about that. Me and kids. And we're done with the geometric pattern. So we've done the numeric pattern. We've looked at the geometric pattern. But what about now numbers that don't really have a common difference or a common ratio? Why would they want to make life difficult for us? Well, it can be what it is. So we just need to know how to maneuver around such scenarios. For example, here, let me use a different colored pen. I have from 0 to 1, okay? I can't really say multiplication or division because anything multiplied by 0, remember the properties of 0 and 1? So anything multiplied or divided by, anything multiplied by 0 is 0. Anything divided by 0 is a math error. So I'm not going to look at ratios here. It must be addition or subtraction. So if I go from 0 to 1, then I have added 1. But now if I go from 1 to 1, I've added 0. So what's going on? From 1 to 2, I've added 1. From 2 to 3, I've added 1. From 3 to 5, I've added 2. So, geez, I cannot see a pattern here. So I need to go back and just see what else can we do here. Okay. What if I look at these two terms and I add them? 0 plus 1 will give me 1. 1 plus 2 will give me 3. Okay. And then 2 plus 3. Sorry. Yeah. I missed 1. Let's try this again. So 0 plus 1 gives me 1. 1 plus 1 gives me 2. 1 plus 2 gives me 3. 2 plus 3 gives me 5. 3 plus 5 gives me 8. So there's the pattern. But here, guys, you really need to focus and try to see what would work. Okay, so basically, what is the rule description? We add two terms to get to the next. So how do we get the next three numbers? I'm going to say 5 and 8 gives me 13. 8 and 13. Okay, let's see. 8 plus 13 will give me 21. All right, so that's my next term. And then 13 plus 21 will give me 34. All right, those are the next three numbers. Now let's look at the second scenario. We have 2 and then 4. So I can see, okay, here it's an increasing pattern, right? And I see maybe a common ratio could work. I don't know. So if I multiply it by 2, I get 4. But if I multiply it by 2, I'm not going to get 16. I'm going to get 8. What did I need to multiply by in order to get 16? I have to multiply 4 with 4 to get 16. So basically, do you see, I'm multiplying a number by itself to get to the next. Okay, a number by itself to get to the next. So the rule description, you square the term to get the next. Because in order to get 4, I squared the previous term. In order to get 16, I squared the previous term. So now, what are the next three numbers? I'm going to say 16 squared. Okay, what will that give me? Okay, 16 times 16. That's 16 squared. Remember, squares, cubes, and all. So it's 256. Now I'm going to say 256 squared. Okay. So 256 squared, or 256 times 256, 65. Oh my goodness, that's a big number. 65,536. And then the last term, I'm going to take that answer and square it. Woo! It's so big. All right. But yes, it's billion. All right. So we have 4,294,967,296. Sure, but can that kind of money locate me? Yes, the money in my bank account must do exactly that. Anyway, let's look at the third scenario. So we have 2, then 3, then 6 and 15. So if I were to, I can't multiplying, but if I'm to add, I'm adding 1, 3, and 6. There's, if I'm adding, I'll add 1 there, I'll add 3, but they'll add 9. So it's not really working out there. So what would I have to do? Okay. You are already seeing. Okay, so this pattern over here, not very common. One would have to really think about it. So for me to get to 3 from 2, if I look at the rule description, we need to subtract 1. If I subtract 1, I have 1. And then I multiply by 3 in order to get to the next. So 2 minus 1 is 1, and 1 times 3 is 3. 3 minus 1 is 2, and 2 times 3 is 6. Okay. Alright, 6 minus 1 is 5, and 5 times 3 is 15. Alright, 15 minus 1 is 14. 14 times 3 is 42. So that's the next term. 42 minus 1 is 41. And 41 times 3 is 123. 123 minus 1 is 122, and 122 times 3, 122 times 3 is 366. Okay, and then lastly, from 1 to 3, I see that I add 2. From 3 to 6, I add 3. From 6 to 11, I add 5. No, 7. My goodness. No, it's 5. What am I talking about? 11 minus 6 is 5, not 7. 6 plus, okay, I'm tired. 6 plus 7 would be 13. But 6 plus 5 is 11. All right, so cool. And then from 11 to get to 18, I have to add 7. Okay, so is there a trend here? I already read the rule description, but yes, there's a trend. These numbers are actually prime numbers. Remember when we spoke about prime numbers at some point? A number that can be divided by itself and only 1. Okay, so the only factors for 2 is 2 and 1. The only factors for 3 is 1 and 3, or 3 and 1. Okay, and so forth. So basically, we're adding consecutive prime numbers. Okay, so now how are we going to get the next 3 numbers? Okay, if I look at the prime numbers, we have 2, we have 3, we have 5, we have 7. 9 is ampur. I almost said 9, but it's not, because 9 has factors 3 as well. So 9 doesn't count, 10 doesn't count, but 11 does. 13 does. 14, 15, no. 16, 17, 18, 19. Okay, so we have enough. So from 18, I need to add 11. If I add 11, I am going to get 29. And from 11, I add 13. So if I add 13 to 29, what will I get? So 29 minus 13, 29 plus 13 is 42. And then the next one is 17. So 42 plus 17 is basically 59. So you can see here, these patterns can be very tricky, especially if they are not numerical patterns or geometric patterns. So yeah, now let's get to an exercise. Okay. Now that I think about it, I did not describe the rule of the pattern, sorry. Exercise 4.2, we stated the next 3 numbers, but we didn't describe the rule of the pattern. So I'll just say it in words. Here, the rule, multiply by 3 to get to the next term. B, multiply by a half to get to the next term. C, multiply by 5 to get to the next term. You will write it down, right? Cool. So now it says, fill in the open spaces using the rule in the brackets. So in this case, because it can get a bit tricky, they at least make it simple for you. So now here, we will have to square consecutive, the square of consecutive numbers plus integers. All right, so now let's see what happens here. So here, we have 25. 25 is actually 5 squared. 36 is 6 squared. 64 is 8 squared. And 81 is 9 squared. Okay, so now what are we going to do here? I'll have to look at 7 squared, right? And what is 7 squared? It's basically 49. All right, so we look at the square of consecutive positive integers. Okay, so now I see here 5 squared, 6 squared, 7 squared, 8 squared, 9 squared. This one has to be 10 squared, right? And so 10 squared would be 100. So what was the rule? You basically take the square of the consecutive numbers of the positive integers. All right, these are positive integers, by the way. And then now for B, it says add the square of the number to get the next term. Okay, so we have 1 squared, which is 1. So you add the square of the number. Okay, so 1 squared plus 1 is 2. All right, cool. 1 squared plus 1 is 2. And then 2 squared plus 2. 2 squared, remember, is 4. So 2 squared plus 2 gives me 6. Okay, 4 plus 2 is 6. Now 6 squared is 36. And we're going to add 6. That will give me 42. All right, I hope you get it. You add the square of the number. Okay, that's why we keep adding it to the next term. Oh, sorry, to get the next term. So we see here 1 squared plus 1 is 2. 2 squared plus 2 is 6. 6 squared plus 6 is 42. Now 42 squared. 42 squared plus 42. It must give me 1806, or else we haven't been doing the correct things. Okay, so let's shift it this side. So if I have 42 squared plus 42, and we get 1806. I'm happy. Okay, now let's go to C. We have 1 and then 4 and then 9, and then it says, the rule says squares of consecutive natural numbers. All right, so 1 squared, what is it? That will give us 1. 2 squared will give us 4. 3 squared will give us 9. 4 squared will give us 16. 5 squared will give us 25. 6 squared will give us 36. 7 squared will give us 49. Simple enough. And then we have n to the power 4, where n is a natural number. So 1 to the power 4 is 1. 2 to the power 4, I'm assuming we can check. 2 to the power 4. Do you see it's 16? Now what is 3 to the power 4? 3 to the power 4 is 81. And 4 to the power 4, what would that be? It is 256. And what is 5 to the power 4? It's 65. Okay, so that's basically it, guys. We are done with looking at patterns that don't really have a common difference or a constant ratio. Now the next section for number patterns is tables and rules. All right, so the rules of some patterns can be written as formulae and can be used to get terms required to complete a table. So here, when we have tables and rules, you see with previous patterns, let's say, for example, I'm looking at exercise 2A. And I wanted, instead of looking, let's say I could see that there's a pattern over here, and I had to fill in this missing value. So I see this is term 1, that's term 2, term 3, and term 4. By using the tables and rules, I can just go straight to term 4 and ask myself, what is term 4? Or go to term 6. and ask myself what term 6 is and get this answer. Okay, but let's look here. So in this example, we have been given this rule, okay, and the rule is y is equal to x squared. Okay, this is the rule. When you get to grade 10, 11, and 12, you will learn that this is actually a quadratic function which looks like this. Okay, but let's not even go ahead. Let me not scare you or excite you yet. Let's stick to this rule. So y is equal to x squared. So here in these missing blocks, I'm trying to get the values of y. So basically, if x is 1, what would be the value of y? Okay, remember we said y is x squared. Now x in this case is 1 and we're squaring it. So basically y is 1. Okay, what you're going to write down is simply 1. Now if I go to the next rule, let me rather put it here. The next one, I can say y is equal to 2 squared because x is 2. So what is 2 squared? It's basically 4. And if I know that y is equal to 3 squared over here, if I substitute 3 in the place of x, I will know that 9 is my value for y. Alright, and if I wanted to jump to 4, I simply put y is equal to 4 squared. In the place of x, I put 4, and 4 squared is 16. So if I wanted to jump to x is 10, I would simply say y is equal to 10 squared. Okay, and just leave out the brackets, and then my y value will basically be 100 if I wanted to know further. Okay, other values, as long as they have given me this relationship in terms of a formula. Okay, like we said here, the rules of some patterns can be written as formulae and can be used to get terms required to complete a table. So that is quite nice. Now, the next relationship we have here is y is equal to 2x plus 4. This is like a straight line with a positive gradient. Okay, you'll learn about all of those soon. Okay, now what they're basically telling me here is, in the place of x, for the first one, I'm going to put 0. So I say y is equal to 2 times 0 plus 4. What is 2 times 0? That's basically 0 plus 4. And what's 0 plus 4? That's simply 4. So y then is 4. If I substitute 1 in the place of x, I basically have 2 times 1, and 2 times 1 is 2. Plus 4, that is basically 6. And you follow the same trend. Okay, in the place of x, we're going to substitute 2. Alright, so 2 times 2 plus 4, so 2 times 2 is 4, plus 4, and that's 8. Again, in the place of x, what are we going to put? We're going to put 3. And then let's go and multiply. 2 times 3 is 6, plus 4 is basically 10. Okay, that is basically how you handle having a table. Now, what if we had 6 over here? Same story. We're going to say y is equal to 2 times 6 plus 4. Okay, so what is 2 times 6? It is 12, and what's 12 plus 4? That is 16. Let me just write it there. And so anything can be calculated, literally anything, okay, as long as you have this relationship that is written in a formula form. And then looking at, is it our last table? Yes, it's our last table. Oh, this boy has been waiting for his father. So now we don't have y's and x's, we have c and a. Okay, so basically I'm looking for the value of c over here. What is the value of c there and there and there and there? So now if in the value in the place of A, if I put 1, 2 times 1 is 2 plus 2, basically 4. So this one, I'm going to go quicker on this. Now 2 times 3 plus 2, that will give me the value of C, right? So I have 6 plus 2, it's 8. And then 2 times 5 is 10, plus 2 is 12. Okay, and then what is the value of C when we have A as 7? So 2 times 7 is 14, plus 2, I have 16. Okay, and that's basically how we use tables. I love tables. The relationship is there. You don't have to go figure it out. And if you wanted a value, let's say A is 20, that's fine. You can get what C is. C would be 2 times 20 plus 2. So 2 times 20 is 40 plus 2, that's 42. You can get any value for C as long as you have A and you have the formula. Thank you. I hope you enjoyed this lesson, and don't forget to like and subscribe to our channel and like our videos. Hey.